I'm glad I can make it here tonight. So I'm sure we'll find some more things to do tomorrow and the next day and the next day after that. It just doesn't stop. I'm from New York, so we're not having this much craze with AI as much as we are here in the Bay Area. So it's been really awesome to see the excitement around it. So before I get started, I just want to know, like, who here in the room has used a small language model at all? Yeah, that's cool. Like, anything in production yet, or just to test out? Has anyone used anything in production at all? No? Cool. Well, at PremAI, we focus a lot on small language models, making them performant so you can build, fine-tune, deploy, and optimize them into production. And we can integrate them into any application, and then super language agnostic and so forth. So there's lots of things that I could say about PremAI. However, this talk tonight really isn't about our product. I really want to highlight like our experience with small language models, bring you from the beginning about small language models and kind of like what we experienced building our own small language model and where we're going in the future with it as well. So at PremAI, I lead product and DevRel. So I've had the opportunity to come to a lot of events like this and meet developers from across many different organizations, and here to tell my story about the power of small language models and what the future is. So nowadays, language models are driving this technological revolution that we have going on, and they're leading to some significant improvements in natural language processing. So large language models always are great, and they pose some new challenges though due to the computational resources and energy that they use. And that's where small language models come into play, or SLMs. Now, given that they can be really effective in certain areas that we'll talk about, small language models really are just models with smaller parameter sizes. Now, what a small language model is today and what a small language model is going to be next year and the year after that is totally going to change. I have talked to some companies where they consider a model that is 13 billion parameters to be small, and others are saying that, no, it'd rather be 500 million parameters and so forth, right? So, as we continue to see the evolution and introduction of Llama 4 or Llama 5, GPT-5 and so forth, like the parameter sizes are going to change drastically. So I would just say, like, if you're thinking about small language models in the next steps, things are going to change dramatically overall. So let's hop in and talk. And I'll tell you what I'm going to talk about today: the problems that small language models solve, where do they fit in, and what my team has learned from creating our own SLM. And we've created a few of them already, and we're going to continue to build some more. Now, the evolution of language models sparks the question: can smaller models with significantly less parameter and memory emulate such emergent abilities in larger language models? There's a lot of really cool things going on with knowledge distillation and so forth that's happening, but we've seen this evolution of models going up and up in parameter size and then kind of going down. Well, this is a little bit outdated. This is from 2022, so things are a little bit changing a little bit here. However, it still kind of poses the same till today. So language models have been shown to exhibit a range of emergent abilities from summarization, arithmetic, translation, and common sense reasoning. As they scaled up in size and are trained on diverse and large amount of data, you've seen that these abilities that are suggested from language models are not only learning the surface of patterns of language, but also acquiring a degree of semantic and logical understanding of the world around us in the text. So although research breakthroughs in CNNs and attention mechanisms have contributed to significant advancements in the recent narrative of AI, it can be encapsulated into one concept though, and that concept is scale. So when we're increasing data, model size, computational resources, this has led to the enhancement of performance and the use of energy. The notion that bigger is better is frequently accepted. We live in America, so everything's big. I work for an Italian company, so when they here this week, they actually think everything that we eat is huge. This is frequently accepted without any question. So, however, it's essential for us to consider the consequences of developing applications that are using the largest available models. So small language models rely on more pre-existing knowledge and semantic priors. And this is gained through pre-training and even with examples that contradict this knowledge. So in contrast, large language models can overcome their pre-existing knowledge when provided with examples to go against it. So despite potentially having stronger pre-existing knowledge compared to the smaller models, we'll see, kind of the difference here. And so in other words, smaller models kind of stick to what they're taught during the pre-training process, and even show some conflicting examples between large language models. So what problems do small language models solve? So they excel in simple tasks, such as, they're great in scenarios where internet connectivity is limited or unavailable. They can be deployed directly on device, on edge, on premise, on servers, and enabling local inference. So this is all without relying on cloud-based services, which is super powerful for the next step of where small language models are going. So when I mention edge, for those who don't know, that can mean on tablets, on phones, in automobiles, right? So think about all these other places where there is a processor that isn't a GPU or an LPU or a TPU or whatever chip all these companies are coming out with. You carry one inside of your pocket every single day. And this is where small language models can definitely excel, because we are able to run models that have this pre-trained knowledge, and even combined with knowledge distillation, we can create a very powerful companion on your own device. Look at what they're doing with Apple Intelligence and what's happening at Google Pixel as well. This is an evolution that we're watching right in front of our faces. So also in applications where near instant response is crucial, such as a real-time conversational AI or like sensitive decision-making systems. So in like any type of emergency application that's being made, small language models can excel there because of the reduced latency that it takes to get a response from the language model itself. Also for organizations that are on budget constraints, small language models use less computational resources, which means that you can save your organization money from doing so. So they offer a cost-effective solution, and their smaller size translates to different computational requirements by reducing the need for expensive hardware. So this kind of leads back to edge devices as well, right? GPUs are not cheap, and it's much different from how they used to be. So during the development and testing phase, where resources are limited, again, small language models can be a developer's best friend, right? They can easily be integrated into resource-constrained development environments, such as local machines or low-powered servers, and allows developers to quickly iterate and test their applications and fine-tune models without a costly infrastructure. So this is great, like a really cool example. Nowadays, you're seeing that there's this model that's a larger model that may act as a teacher, and the smaller models act as a student. This concept is, prevalent within this point here. Now, for specific tasks to achieve better fine-tuning out the box versus LLMs, while large language models offer an impressive out-of-the-box performance, based on general knowledge, they may not always be the best fit for your domain-specific task. Whereas when you're fine-tuning small language models on domain-specific tasks, you can yield superior results compared to the generic knowledge that a large language model has. So by focusing on narrowing the task and leveraging relevant training data, a fine-tuned small language model can capture the nuances in terminology and patterns that are targeting a specific domain and leading to improved accuracy and relevance. And that's pretty much what we also work at Prem. So in summary, small language models are really powerful, versatile for a wide range of applications, and they enable offline inference, handle latency constraints, can save you money, and so forth. Pretty much what I explained before. And again, just in plain simple words, SLMs are fast, they're cheap, they're predictable, they're customizable, and they're great for privacy, because that's what edge devices allow you to have. Now, just because I'm here talking about small language models doesn't mean I think that they're the best, right? Like we're doing a lot of research. At PremAI, we're also an applied research lab. We work together with some of the top universities in Switzerland and across Europe as well to then help evolutionize how small language models are being used in production. And also on top of that, fully homomorphic encryption to then increase the privacy behind these models as well, since there's clearly like this privacy problem within the AI space right now. So while small language models offer numerous advantages, there's certain challenges that we face, and that could be for limited contextual understanding. So it is like, to a point where if you use a pre-trained small language model off the rip, it has an inferior contextual awareness compared to a large language model that's pre-trained. So due to fewer parameters, of course, and small language models may struggle to understand and generate responses that require deep contextual awareness and understanding. But this is where fine-tuning, RAG, and other techniques also come into play, and like knowledge distillation as well. So with shorter context windows, you may have a limited ability to maintain the context of a long conversation with a small language model. But then that also leads into the evolution of agentic AI and having a hierarchical orchestration between a large language model and a swarm of smaller language models that can work together in order to complete domain-specific tasks agentically. So they can reduce, when you're using a small language model, you may come across reduced accuracy and performance. So smaller models often provide less accurate and lower quality outputs compared to large language models, and particularly in nuanced complex tasks. So just pretty much like a generalization of that. You may come across less creative responses from a small language model. So due to limited training data and fewer parameters. And I'll say it again, this is again where something like knowledge distillation comes into play that can improve this, but it does take a lot of work to do. And small language models may produce less creative generic responses and also repetitive outputs. So something to look out for. There's this data dependency. So training data quality is super important, and the performance of SLMs heavily relies on high quality data, all right? So the inaccuracies and biases of training data can significantly impact their performance, and their limited knowledge base of SLMs may also lack the extensive knowledge found in a larger model. And then there's some scalability issues and task-specific limitations. While SLMs can be fine-tuned on specific tasks, they are generally applicable across a wide range of tasks as well, and they have some adaptability issues where they can struggle in rapidly evolving or requiring updates to remain relevant. But that's where tool calling comes into play as well. So there are some really great emerging use cases for large language models. I'm sure I don't have to explain what RAG, retrieval-augmented generation, is here, but there are some really cool advancements that are happening with RAG and small language models. We released Prem1b, which I'll talk a little bit about from our experience, that heavily focuses on just RAG implementations. You're seeing a lot of cool things happening with small language models that are also multimodal. And data labeling and using few-shot prompting is starting to advance there. SQL generation, which I'll talk a little bit too, because we released a model called Prem text to SQL as well, where SQL generation is really changing the game. And then, of course, agents and function calling. So something to really look at. So just on the topic of function calling, open source small language models like Mistral 7b, Functionary 2.5, or Llama 3 8b are revolutionizing function calling on the open source level. Not that the closed source models are not doing so, but these open source models that are coming out that are much smaller are great for proof of concept and even rolling into production as well. And it can also help save your organization money. So think about having a small language model that's open source and running on an edge device. You can cut your costs significantly. Now, these models offer performance, efficiency, and accessibility, allowing developers to customize and deploy on a single GPU or a single processor, whatever one you're using. The open source nature of these models democratizes the access to these advanced functionalities and the function calling capabilities that come with them. and it fosters collaborations within the developer community. So I actually met with like a company this week called Two House, which is doing that as well, who we're looking to collaborate with, who has like actually changed the whole function calling game where within 3 lines of code and using their SaaS, you can literally just have function calling added to any language model like that without having to have a huge amount of JSON that's just in the middle of your code trying to interact with some type of function or API. They've really honestly just made things a lot easier for developers. So developers can quickly prototype and deploy applications without expensive infrastructure and with the needs so forth with tool calling. So traditionally, RAG has been associated with large language models, if we're looking back to GPT 3.5 and GPT 4, which have demonstrated some impressive performance in this domain. But these models with vast knowledge and embedded parameters have the ability to generate fluent and coherent responses while incorporating information from external sources as well. So, but however, such large language models for RAG applications come with certain drawbacks. There's always hallucinations that happen. So these models with billions or trillions of parameters require an immense amount of computational resources and storage capacity, right? So the vast knowledge that these models come with that are embedded with them, while impressive, may not always fit your domain-specific task and can stay relevant even with RAG. So this is where small language models and RAG are like best friends in a sense, because small language models offer a more efficient and targeted approach to handling RAG applications by focusing on specific domain-specific domain tasks, and SLMs are designed for acquiring the knowledge from RAG while maintaining the compact size and staying relevant. So just imagine a scenario where you build a RAG system for a specific domain like healthcare, who we work a lot with, or finance, or entertainment. So instead of relying on general purpose knowledge, your model won't be so broad when you have a small language model, and you can create an SLM that's specifically for that domain. So that also kind of is relevant to our work PremAI with Marvel Studios, who has proprietary IPs and wants to make specific models for all their superheroes and stories that they're telling, and animated series and so forth. So if you want to learn more about that too, you can come and find me and I can talk more about our use case with Marvel. So if we embrace this, this notion of using retrieval-augmented generation, graph RAG, and whatever comes after that, with small language models, you can unlock some new frontiers when it comes to this whole evolution that's happening within AI. So at Prem, again, we're an applied research lab and a startup. We have a SaaS as well that you can use. But we also focus on making open source contributions, and we're going to be open sourcing our platform soon. But before that, we also released Prem1bChat and Prem1bInstruct. And these are transformer-based decoder-only SLMs, and they're trained on next token prediction. So the architecture for this model is based on Llama 2 and Tiny Llama with flash attention. So just note that Tiny Llama was trained with the context window of the context length of 2048, but Prem1b has the context length of 8192. So just considering this release with the new models that are come out from Llama and the performance benchmarks, we went with the Llama architecture based on transformers. So we explored a lot of other things like Mamba architecture, MOE architectures, H2O, stable LM, Phi, Llama models, but we ended up on Llama 2. So just talk about some of these results here. Tiny Llama appears to be a top performer in this case, and it shows some strong performance across different tasks. And I could talk about all these other ones as well, but I mean, essentially our model isn't perfect and that's open source. However, we're continuing to make more and more improvements. We're not a company that provides small language models at the heart, but we do this in tandem with our research and what we're doing with our platform as well. So we're continuing to improve these and add more models to our whole offering. So even with that being said, we have Prem1bSQL, which we just released the other day, who like my team and I have worked on. So Anindya, who is one of our ML engineers and DevRel at Prem, worked really hard on Prem1bSQL and the fine-tuning process of that as well. And you should definitely check it out. It's benchmarking pretty well against some of these other models for text-to-SQL, and we're going to continue to actually build it up and get to a 7 billion parameter model for text-to-SQL, which is another emerging piece of the industry to capture here. So on our platform, you can fine-tune, deploy models super easily, small and large, open source and closed source. That being said, I mean, that's pretty much it for my talk today. If you'd like to learn more about what we're doing at PremAI and like how small language models can affect your organization, please come find me. And if you have any questions, I'll be here for a little bit. Thank you. Like in tandem, like we're a research lab, and then we also have our own startup and SaaS and so forth. So on the research side, we are making our own small language models. We have about maybe 5 or 6 different ones out on Hugging Face right now with Prem text-to-SQL, the chat and instruct versions, and a few other ones that we have available. So we do work on our own, and we're going to continue to push out some more, and that we're fine-tuning for different use cases. Like we have our own clusters in Finland. We work with the University of Switzerland and Italy as well. So we have access to work with them in their research lab, where we're at the forefront right now, actually a fully homomorphic encryption that we'll put on top of the small language model. So we're working with governments and different entities that have proprietary data or sensitive IPs and so forth. We can do that. But on the other end, on our SaaS, on our platform, we also have the ability to, we host models. There'll be host models all the way from open source, GPT, Anthropic, Google Gemini, Gemma, all the really popular closed source and open source models from Llama, Mistral, and even the uncensored ones. You can use those on the platform, integrate with a few lines of code, and you don't have to have any type of vendor lock-in. Our whole purpose of what we do at PremAI is to unlock AI sovereignty, so that when we're working with certain companies like Marvel, or we're working with the Swiss government or other companies over there, they can ensure that when they work with us and they want to use models across the board from open and closed source, that they can own their models, own their data, and trust and have a trusted place that they can host it on. So we do on-premise deployment. We have virtual private clouds. So we come up with a bunch of different solutions for companies. So pretty much we have our own, and we have everybody else's. So we have a couple right now that are really heavily on small language models and even agents as well. So we have, and I can bring it up here actually. BitGPT.network is in our family of products as well. BitGPT is a decentralized AI wallet that you can chat with, and it uses Prem's SLMs and fine-tuning as well, so that it's a wallet that you can actually chat with and send funds, check on the market. Pretty much you see from this example here, and pretty much it helps make blockchain, crypto, and trading more accessible to folks, rather than having to manage 3 different hot wallets, a cold wallet. One of the biggest problems within blockchain is just adoption. So this is kind of where we have this intersection of AI and blockchain. And at the core, we started as a Web3 family, right? The founders of Prem are from SingularityNet and a few other Web3 startups. And we came here. We have our use case with Marvel Studios with them, and then we also have another small language model that's being used for a payment platform called Celix. And Celix is a payment processor and marketplace, and they're using Prem's SLMs to actually capture fraud detection as well. So there's a lot of people this payment platform allows you to pay with fiat currencies and cryptocurrencies, but there's a lot of sketchy people out there that may be doing some type of fraudulent activity. So they use the small language models to capture that beforehand, and make sure that people are having a smooth process. So they're coming out with some really cool stuff. They have a really easy to use API and SDK, and we're looking to collaborate with more companies and push out some more things. So check out our documentation if you want to learn more about Prem, and if you work in an organization that is in Gen AI, of course, talk to me, and we do a lot of things in open source. So kind of back to some of my slides before, they're not perfect, but the things that there's definitely some hallucinations that happen. I would say if you just use a pre-trained model without any type of fine tuning or RAG or anything else like that, you'll definitely see it. And even with RAG, there's still hallucinations. But the things that do make it better are knowledge distillation. And then we're doing a lot of testing in this hierarchical orchestration of having a larger language model sit at the top, kind of like something similar to federated learning without the decentralization piece of it, where the larger model can sit at the top. There's a central data point, and the SLMs can then capture the data from there. So it does improve the accuracy in that sense. However, they're not, I don't think they're perfect. And even as we're going into this next step with agents as well, I don't know, someone needs to point me in the direction where agents are being used really well in production. And because a lot of it's prompting and other things that are going on. So it's pretty tough. But I would say with fine tuning, RAG, knowledge distillation, we've seen improvements on our end. And this is something that we want to, fully bake into our platform further and further and improve. So that's why we're doing a lot of research on it.